All right, class.
Yes.
I said the PowerPoints are right there. You were too busy talking about wasting all your money. No, yeah. Sorry, I didn't know you weren't paying attention. Cause anyway, all right, rates of change and the derivative. Now, rate of change, it's like miles per hour. Okay, it's normally some type of distance or unit of measurement over time. Okay, time is normally how we're measuring. Find the equation of tangent line and normal line. Okay, so all this stuff, it's all beauty, eh? Definition of a tangent line. So, tangent line is going to be the graph of the function at a point containing the point and not and having the slope. So, we're basically finding the limit as x approaches c. Okay, so I get there where x and c should be. So right here, my distance is my delta x over my delta y. It's the change in y over the change in x. And I want that distance for my x to be 0. So as x approaches c, I want that to be a 0. But I can't have 0 in the denominator because that would be undefined. That's why we're finding the limit as we're finding that. So I'm finding the slope at a singular point. And notation looks like this. F prime of c. With the little tick mark right there, that's f prime of c. That means that we are taking the derivative. All right, find the equation of tangent line and the normal line. So now, right here, tangent line. Highlight, circle, underline this. This is the equation of a line. That is the equation in point slope form. The normal line is also in point slope form, but the difference here, the normal line is perpendicular to the tangent. The normal line is perpendicular to the tangent. That means that the slope is going to be opposite reciprocal. Slope is opposite reciprocal. So opposite and reciprocal. So I take that whole thing, I flip it over, and change the sign. So normal line and tangent line. You're going to see a lot of these. And you have to plug them into those equations. All right, find the slope of the tangent line to the graph at x squared at c is -2. Okay. -2. All right. Now, couple different ways of doing this. This is the easiest way. I know you guys are all writing this down because it wasn't on the page in front of this. All right, you guys ready? So, right here, what does this mean? What am I doing with x plus h? I'm what? Not moving it. I'm going to plug it in. I'm going to plug it into what function? This is f of x plus h. So inside, everywhere you see an x value, you're plugging in x plus h. Huh? Yeah. So right here, this is going to give me parentheses x plus h close square minus, what is my f of x? X squared. All over. Now expand this first part right here, and I get what, 2xh. My fat head's in the way. No, h squared. Minus now, this is where some magic happens. What's going to happen to my x squareds? And I go away, I'm left with 2x, yep, all over. What do they have in common? And please don't do the math sin. They have an h, so I need to take the h out. So I need to factor it out. So factoring it out, I'm going to have an h quantity 2x minus h over h. Now this is not a math sin. This is correct.
Wait, how did you get the minus h squared?
Oh, I'm sorry. It should be plus h squared. Thank you, thank you, thank you. Yeah, h's cancel now. That is not the math sin. Now can I plug in 0? And I'm left with? If h is 0, I'm left with?
0.
Just 2x plus 0, right? Which is just 2x. And we wanted to find out what it was when c is what? -2. Okay? So technically what we just did here, this was f prime of x. And so what we can do is f prime of -2 for my notation. So that means that in my f prime function, what am I going to plug in? -2 everywhere that I see every time you see an x, right? So 2 times -2? -4. Was that crazy, Anthony? Do you like notation how we actually jumped to here? Because I just introduced this one right here. You okay? You didn't zone out for a second? Your eyes didn't get all glossy. Okay, I got you. So we found the slope of the tangent line to that graph at that point. So my slope was -2. Use the result from this to find the equation of the tangent line when this. So the equation of the tangent line so we said f prime of -2 was -4, and we said that that is supposed to be my slope, right? Yeah, that's the slope. And c, what was the c? -2. But what did that really represent? That represented my, what was that? That was my x. Do I know what the y is for my function? No. So let's figure that out. So we know what f prime is. What's f of -2? What do we get? So -2 squared is 4. So now I have a x value of -2, I have a y value of +4, and I have an m, which is -4. So what form am I going to use to find this? I'm going to use, I'm hoping more people pay attention because some people are zoning out. Point slope. Okay, point slope. We're going to plug in point slope. It's that formula I had you guys circle, box, or whatever you did there. So the formula in standard notation, without all those f of x's and all that, y minus y1 equals m quantity x minus x1. That's probably the way that you recognize it better. With the f primes and all that other stuff. So let's go ahead and plug in what we have. Y minus y1, that's y for my point, which is 4, equals m, -4, quantity x minus x1, so x for my point. So minus 4 equals -4x minus 8 plus 4 y equals -4x minus 4. And that is the equation of the tangent line. On the AP exam, this is correct. This will get you full points. Just stop right there. Except if you have to use it, because usually from there they'll use it. They'll say, "Hey, use this to estimate what the next one is," or something.
So what is
What is what?
So there's f of x, then there's f. What is it called again?
Prime.
What is f prime?
Hey, I already went.
Oh, so f of x is the function, and then f prime is the tangent line of
No, not the tangent line. It's the slope.
slope.
Okay, so right here, this is a slope at a point. But if it just says f prime, so this is the equation of the tangent line. To get the equation, to find the slope.
Okay, so then the f prime is just the slope, and then you plug it into point
The point,
slope form to find the actual equation of the tangent line.
yes, because here, let me graph this real quick so you could actually understand this part.
That prime is just the m, and you just do the whole point slope
Mhm.
form to just find the actual y-intercept or whatever that is.
So
Okay.
this is
So you just might lump
the equation at any given point. And I'll show you here in a second. And it was just x squared, right? There you go.
the equation at any given point. Help me find the slope. Find
6, 6. All right, let's go 1. So at 1, my slope was 2. What did we say? -2? So I'm going to do it again. Menu, 6, 6, -2. I don't know if you can see it. It's like way up here in the corner. And we got a slope of -4. So if I were to draw a tangent line, you guys, a tangent line is a line that touches my function only at one singular point. So my tangent line would be right here, touching it just at one point. My slope here is -4. Just like over here, the slope is +2. It's changing every place I put it. Right? So the equation of 2x, my f prime, right? So if I told you that that is my equation for my slope,
At
what's
any point.
at any point,
So is it like the rate of change?
kind of. So watch. So think of it like this. So at 10, where x equals 10, using that equation, now that you made, using the limit process, okay, we got f prime. So if I say it's at, what did I say, 5? 10. 10. What would my slope be? It'd be 20, right? Okay, let's try it. Menu, 6, 6. The slope is 20. So at any given point now that I've done that setup, at any given point, if I have this, I can figure out the slope at any point on my function. Does that make sense?
Yeah.
Okay.
And how is it different from rate of change?
This is. Rate of change is the slope. It's miles per hour. So if I'm doing this and I'm looking at it as,
So is f prime the rate of change or the equation for the rate of change?
it's the equation for the rate of change. So we know a rate of change as a singular point. We gotta ask what the point is to get that, to be able to find out what that rate of change is.
You were talking about it like with time as a factor in range, right?
Yeah.
Okay, does it make sense if I explain it like if your little like function is your like road you're traveling on, if you were to take a picture of your dash at one specific point, how many miles per hour are you going? Is that kind of
Yeah, it's miles per hour basically.
But
So
like,
in this problem here, so if you look at it like this as a negative velocity, so -2, that means I'm traveling backwards, right? Okay, so I would be going at the slope and rate of change, so it's going to be 4. That's my rate of change. My rate of change is always, over 1 anyway. Okay, rate of change, it's always, so just if I told you it had a slope of 5, mentally you know it's up 5 over 1, isn't it?
Yes.
Yes.
So for this function, the rate of change is constant. But what happens when?
It's not constant.
Isn't it?
Nope, it's at that point.
Before?
At that point.
But isn't it every point?
No, that's why on the calculator I plug in different points and I get different answers. So as I plug in -2, I got a -4. So my slope, my rate of change is -4. When I plug in 10, my slope is 20. So my rate of change is 20.
So then, with 2x, that's always?
2x is the equation. That's why we call that the f prime.
So 2x is the rate of change? Or?
This is, it's the derivative. The derivative, the first derivative gives me the slope of the line. And the slope is rate of change. If I'm looking at it in physics sense, it is the distance over time. But then if I'm looking at it as a velocity, it's the change of the change. Is that going up at a steady rate, or is it increasing or decreasing? So that would be a distance over time squared.
It's just gonna not make sense until it makes sense. From last year, it took me like a month to like actually understand what a limit is or a derivative.
So, but yeah, we just started with it right now. So this is the piece right now. Okay, and that's what we're applying. So I had another part to his question, right? Good questions though. Find the equation of a normal line at the point -2, 4. Now, what do we say the normal is?
The negative reciprocal.
Opposite reciprocal of the slope, right? Opposite reciprocal of the slope. So that means that if my f was x squared, f prime of -2 was -4, and then perpendicular to that is opposite reciprocal. Opposite. Miss Johnson, I know you're not taking a nap right now, right? Because you start snoring when you get really in that deep sleep there. It's pretty bad, because I got a really good mic and it picks it up. So, opposite reciprocal. If this is negative, that means the opposite must be positive. And if it's reciprocal, this is 4 over 1. My opposite reciprocal is?
1, 4, positive.
Positive 1 over 4, like that. Now, we're using the same point that was given to me. My point was -2, 4. So I plug that in. Y minus 4 equals positive 1 over 4 quantity x minus -2.
What slide are we on?
Are we still on time wave three?
Yeah, there's like a whole bunch of different ones on that one. Alright, so let's go through, do some distribution. So y minus 4 equals 1 over 4x plus 1 over 2, 1/2. And then I go plus 4, and over here to plus 8 over 2. Why did I add 8 over 2 over there?
They all have the same.
I need common denominators, don't I?
Yeah.
Because I'm adding this one to this one right here, right? And since I'm adding these two together, then why not, yeah. I know I'm adding 4. 8 divided by 4 is, or 8 divided by 2 is still 4. So, and that's going to give me y equals 1 over 4x plus 9 over 2.
And what does it need to be a normal line? Like, what is that?
It's perpendicular to the tangent.
That's all it needs?
Yeah. So I'm going to add these to the, so right here, let's go I did see your hand. What's up?
Is that B?
I think it's B. So let's put my first equation here. So I'm going to go tab, and it was y equals, was it negative 4x for the tangent? What was the equation? Negative 4x
Minus 4.
Yeah.
minus 4? Okay. All right. So that's the tangent line. So it touches at a singular point right there, and now I'm going to put the normal line. And that was control divide 1 over 4x plus 9 over 2. The reason why it doesn't look like this is because it's not a square window, but it is perpendicular. If it was a square window, you would actually see it better. So menu, 4, and there was an option for square. There you go. Did I not click on it? I guess I didn't click on it. I don't know what happened. Ah, I screwed it up. Okay, anyway. But yeah, perpendicular right there. And that's what a normal line is. It's perpendicular to the tangent. We got what, 5 minutes left? Yes, okay. So I'm gonna go back. But these are all good questions, so I don't wanna leave off when you guys are asking some pretty good. Graph of the tangent line and the normal line on the same set of axes. There we go. So now that we see what those graphs are compared to each other.
And just real quick, because I didn't catch that last part of the normal equation. Is it we do the opposite reciprocal of both the slope and the
No, just the slope.
just the slope? So
Just the slope. That's the only thing I changed. So right here, right here, that's the only thing that's different. Point slope, and I do the same thing, but right here, perpendicular slope.
Can you go back to your work real quick? Just so I can just like process the symbols.
This symbol right here means perpendicular.
Oh, I see. Okay, I'm seeing right there too. You're looking one for the. Okay, I see. Okay.
You actually did know this, right? I'm not crazy.
The perpendicular.
Yeah. Yeah? Okay. I have used symbols and such that someone's like, oh, I've never seen that before. I'm like, okay. Alright, we good? Alright, so that's it for today. If you want to try to do some of the problems in your packet that I gave you guys, you can. Other than that, like, share, and subscribe. Tomorrow, what are we doing? Going over the test.